So when you draw something like a line of best fit, and your friend draws something like a line of best fit, and what we did previously, depending on what your line of best fit was compared to somebody else's, everybody gets a slightly different equation, and then you might start an argument. My line of best fit's better than your line of best fit. And the question is there a best line of best fit? And how would you find the best line of best fit? So you want the line that goes as close to all the points as possible. What would that look like? And that's where we're going to today on how to use our calculator to find that. The idea looks like this. Each point has a residual, and that residual is the vertical distance away from a line of best fit. And just like we calculated variance, where sometimes we have points that are above the mean, sometimes we have points that are below the mean, and we squared them, we're going to square these values as well. And if I would add up all of those numbers squared, I want the smallest number possible. Because if I have the smallest number possible, then though all of the points are as close to possible to the line. And your line of best fit is kind of like an average all the way through. So what we have is if our residual is positive, it's above the line, negative below the line. If it's equal to 0, it is right on the line. So we want the smallest possible value of adding up all of the squared numbers of that so that our positive and negatives don't cancel out. So by squaring, everything becomes positive, and we want that number to be as small as possible. So here are some crazy complicated formulas. The thing to be positive here when you're looking at these formulas is that we are going to be using our calculator. But sometimes before you get to your calculator, it's nice to see everything that comes out. So the slope of our line is going to be calculated by multiplying all of our x, y values and adding them all up. Then adding up all of our x values, adding up all of our y values, and dividing by the number that we have. Divided by adding up all of our x values squared and subtracting all of our x values altogether squared divided by n. So what does that mean if we do an actual question? So here we've got 3 points, 1, 3, 2, 1, and 3, 5. And we're going to want to find the line of best fit, which is that red line, so that the distance of P, Q, and R is as small as possible. So we look at our points. We have our x values, our y values, multiplying our x and y values together, and squaring our x values. At the bottom of that column, I've added all of those up and labeled those. This is our sum of x, this is the sum of our y values, sum of our x, y values, and sum of our x squared values. If we plug these things into our formula that we have, sum of our x, y values, which was 20, and I've got the values here again, minus the sum of the x times the sum of y divided by how many points you have, we get a slope to be 1. The mean point, which is the average of your x coordinates and average of your y coordinates, is 2, 3. And using your slope and your mean point, this becomes the best line of best fit going through those points. So now I'd like you to put those same values into your graphing calculator and follow the instructions on here and see if we can get our graphing calculator to give us the same line of best fit. So once we have our data from the second one entered into our calculator, here it is. We want to sketch our scatter plot and then find our equation of our line of best fit. So I'm going to go back to my calculator. I've got the data put in already. So I'm going to go out of here, stat, calculate, number 4. And this is what mine comes up with. So depending on, I don't know if it's the version that you have, but if you have a different thing show up, we'll see if we can figure it out so that everybody shows up the same. You want to use your X list and your Y list. Leave your frequency list blank. And this one, the store regression, is helpful to have. Store it right into Y1. So there's a couple of ways you can get to Y1. I find the easiest way to type Y1 is to go alpha y equals, which is these menus. And if you scroll over to Y variables, you can decide which graph you want to plug it into. So I'll push enter on Y1. And then go to calculate. So it gives me my line of best fit. It tells me what my A value is. It tells me what my B value is. Another thing that I'm going to get you to do right now is, because it's going to come up later, go second catalog and then push the letter D to go to the letter D's. And we want to find diagnostic, and we're going to turn that on. There it is. And if your diagnostics are on, then that same thing that we calculated before, so stat, calculate, number 4, linear regression, still store this as Y1 and calculate. Now an R squared and an R value comes up as well. And that we're going to get to that on Wednesday's class of what those values mean. But they're going to be useful values as well. Just push enter, and then I redid my linear regression just to show that R squared and the R value. If you go zoom and then number 9 to statistics, that should give you the best window for all of your points, and apparently that's the best line of best fit. So if I wanted to write that equation down, wow, there's a lot of decimal places there. Maybe I'll go back. .117. Okay. Now we've just got our line. We have to use the approximation signs because we're going to estimate this. 0.117 is to 3 sig figs, and plus 83.3 also to 3 sig figs. Now we're going to use this equation to estimate the cost of a 1,000-kilometer flight. So we go back to our calculator. What do I know? I know my x value. Some things that I can calculate using my equation. I can go second, calculate on my graph any value. So if I know that the x value is 1,000, it calculates my y value to be 200.6. Rounded to 3 sig figs, that would be $201. Estimate your equation to find the cost of a 2,000-kilometer flight. Now, of course, I could also solve these ones by plugging 2,000 in for y and solving for x, right? And doing the algebra to figure that out. However, you're going to find that if you use the value part on your calculator, it can get your answer quicker. Now, if I go to type in 2,000 right now, I'm going to run into a problem because 2,000's outside of my window. That doesn't mean your calculator can't figure it out, but we'll need to go to our window and say my x max right now is only going to 1,600, so maybe I need to go higher than 2,000 to 2,500. As a result, maybe I'll make my y max go up higher as well. Looking at my new graph, now my graph goes beyond my data points, and if I try to calculate a value number 1 at 2,000, now it's in my window and it's able to find it for me. And it's estimating it at $318. This is one area where the exam is somewhat flexible on your rounding, because if you used your actual equation to solve for your value, both the a value and the b value are already rounded, so you're using rounded values to find something else, which can cause your final answer to be off. So I find that the graphing calculator is better, but they are pretty lenient with estimated values with your rounding as long as you've shown your work.